So continuing on, so read this little blurb right here. It says the range from the black to the white is called value. And it's good to be aware of situations where colors have different hue but are in value. So hue is basically the difference between these colors. So going from this color to this color to that color, that's a hue. So again, we're kind of shifting between the red, blue, green, and basically the secondary colors. But sometimes they're close in color. In some cases, they can be hard to distinguish. Brightness adds white to an image. Reducing brightness tones down the image, so it makes it look washed out. Contrast is the degree of separation between values. So contrast is basically how we really show distinguished between like a light red and a regular red. Saturation is the measurement of color, so basically the intensity of the color, how bright and deep is that color as opposed to how light is it. So if we look at this figure 5.10, this is basically brightness levels, and so these blocks up here are showing the distinguished blocks between them, and then down here is the gradient, how we can see it as a gradient. Here's the actual picture that shows the contrast levels. So here we have, it's kind of dark, it's got darker tones. This is probably normal, and this is a lighter tone. So here we see the saturation. So full saturation is at the top, so we can see our distinguished colors between one and the other. And then this is called half saturation, so it's not as bright, not as deep. And if you turn saturation all the way off, it basically becomes black and white. The guy that found out about the red, blue, green, his name was Sir James Clerk Maxwell. They kind of show him here in a red, blue, green kind of a format. So what they found out was we had red, blue, green, and when we blend them together, so red and green made yellow, red and blue made purple, or magenta I should say, and blue and green made cyan. And if you mix all 6 of those colors, you actually get white. So the subtraction of the primaries found by Louis Decoux de Haron are red, cyan, magenta, and yellow. So this guy found these colors. So if you take the primaries and kind of mix them together, you get these secondary colors. And then you can actually then mix all 6 of these colors in different formats to get more colors. So if you just take the cyan, magenta, and yellow and mix them, we can see yellow and cyan makes a greenish type color, and then the yellow and the purple make a red, and the cyan and the magenta makes blue. And this time you mix them together, you get black. So when we start looking at websites and how we start blending colors together, really makes a huge difference in websites. And for example, if we take a look at this red button right here, this red button and this red button are actually the same exact button. Same colors, same hue, same saturation, same everything. But when we add different colors as the background, that button is going to look brighter or dimmer depending on what color is in the background. If we take a look at 5.18, there's actually it says the solid gray bar. So look at that. It's a solid gray bar. There's no difference between this bar and this bar. But when we add a gradient background, this bar now looks like it's gradient as well, because we now have contrasting colors. So we see the opposite. So here's dark to light, and here's light to dark, and it makes that look different. But actually, that's a solid gray bar. There is no difference between those center gray bars. So we've talked about the hexadecimal colors. One thing I do want to point out with the hexadecimal colors, let's say we have a situation where I have a 6600FF. Well, since there's 3 pairs of numbers, we can actually make that a shortcut of 6, 0, and F, and that's going to be the same thing as 6600FF. So if you ever have that situation, I think they talked about that very quickly up here. Yeah, so like this guy right here, is 660033, we could actually just write 603 and get the same exact color. So if you ever have a color like that, realize that you can use the shortcut and only 3 digits are needed at that point. So we get into this thing called HSL. And so the first thing we're going to look at is we do have this color wheel, and straight up 0 is red, 90 is green, 180 is cyan, and 270 is kind of a dark blue. Okay, so we have to know basically the colors there. So what we have is this. We're going to have basically, so HSL has 3 basic elements. So the first one is the actual color. So we're going to pick a color between 0 and, was it 300? I think it's 300. Where is that? Well, I believe it's 300. So we got, so there's a 380. What's 180 and 180? That is 360. So yeah, it would be 360. It's just like a compass. So 0 to 360, where 360 is basically going to be red. So that first digit is going to be that. The next digit is going to be the contrast. Is it the contrast? Let's see. Yeah, so the middle one, so the full circle from 0 to 360, and the percentages of saturation and lightness, 0% to 100%. So that's the saturation, and then the next one is lightness, 0 to 100%. So that is saturation, that is lightness. Then we actually add a fourth one, and that is basically the transparency. So we can go from 0.0 to 1.0 as far as saturation. So we can actually change our colors on the color wheel with that, where we can then pick a color, tell it the saturation, and then tell it the lightness, and then the transparency factor. On the color wheel, similar or analog colors are found next to each other. To pick an analogous numbers, simply pick one color on the color wheel and its nearest neighbor to the left or right. So if I kind of pick this color red, and if I go to the left, I will get this more purplish. If I go to the right one, I'll get more red. So those are called analog, whatever. Analog colors, we'll call it. Okay. Monochromatic colors are the colors that are in the same line from lightness to darkness. So those are called monochromatic. So color schemes essentially use variations of value of the single hue using more or less black. Okay, the less black basically is obviously more white. The more black is obviously more dark. So So monochromatic is mean we pick one of these colors and then we pick the darkest and the lightest. Okay, and then we have gradiated colors, which basically then we go in between those from all the way dark to all the way light. We pick a slew of colors in between. So monochromatic is this really dark, the lighter, and then the lightest. And then if we use gradiated, we have kind of a darker red, a lighter red, and a lighter red. Then we have what's called complementary colors, and these are colors that basically go with each other. And that means if we pick a color on this side of the wheel, if we go to the opposite side of the wheel, that is a complementary color. That means those colors they do work together. Notice how we've got red and green, which reminds me of Christmas. So how do you build a color scheme? Well, the first thing you need to do is pick a base color. And here in table 5.1, they basically kind of lay it out as far as white all the way through brown and black. And they kind of tell you what each color basically, what's the trait of each color, and then what's the positive trait and negative trait of each color. So if we then take those different color schemes and then kind of look at them at some actual websites, we kind of can see here where we kind of got some darker and some yellow colors. Here we have kind of some reddish, not really bright red, but kind of an off red. Here we have kind of an orange, and here we have kind of a red and I'm sorry, a yellow and some darker tones. Here we have more green. Notice we got kind of a light green to a dark green to even a darker green. And here we have some purple. And if we kind of went back to each one of these colors and looked on this, the positive traits and the negative traits, well, again, what are we trying to accomplish here? So we would pick our base color and then basically go from there. So then what would we do is then we would look at cultures and colors. So what cultures and what color basically go with each of these colors that we're looking at. So again, white is more of our Western and Eastern, and red is China, India. So we can kind of see the different continents or different areas of the globe that kind of go with the contrasting colors. And then we can basically actually look for some different color aspirations. We can actually go to we don't want to go to Evernote, but it says collect photos, magazines, layouts, and mood boards in an Evernote folder, so you can actually then collect those and see what you think of the different contrasting colors and how they work with each other. If you're mathematically inclined, read the Color Harmonization paper by Daniel Cohen, so you can actually go to that. Cohen or runs through traditional color harmonies while proposing mathematical formulas for automatically harmonizing images without the need of the artist's eye or intuition. So if you're into the mathematical and numerical stuff, you can basically do that as well. We can also go to this Adobe Color. Now this is a great one because what it does for us, we can pick our base color. So once we pick our base color, we can then drag this out, and we can see here's our base color, and then we can kind of see what it looks like. If we want to pick more of a contrast, or we can then basically change the hue, we can change the saturation. So there's a whole lot of different things that we can do as far as picking the color scheme that we basically want for this particular color. So this is a great. Now what's nice about it is it gives us our RGB colors. It also gives us our hex colors. So it's kind of nice. We also have, what is this? The colorcombos.com. We can come here as well and actually pick some colors. Kind of if we're looking for a grouping of colors that goes together, we can find those as well. Here's also Color Lovers. We can actually come here and find different colors. And again, here's the Adobe we just talked about. So here's a picturing color. Picturing a color scheme. We'll cover that here in just a second. We're about out of time, so let's just cut this off here and we'll be back on the picturing a color scheme.